Lesson 2.7, Future Value of Investments. Our introduction article. How can you effectively plan for the future balance in an account? Please read this article so you're prepared for the lesson to come. There's some terminology that you need to know. Future value of a single deposit investment, periodic investment, biweekly, and you have a formula down here at the bottom. Example 1. Rich and Laura are both 45 years old. They open an account at the Rhinebeck Bank with the hope that it will gain enough interest for their retirement by the age of 65. They deposit $5,000 every year into an account that pays 1.25% interest compounded annually. What is the account balance when Rich and Laura retire? If they are depositing money every year, this is our formula, where you have a parenthesis within a parenthesis, and then there's also a fraction. So looking at this, we have the variables B, P, R, N, and T that we need to identify. P is no longer principal. P is the amount they deposit every time. So let's go ahead and read the problem again. Rich and Laura are both 45 years old. They open an account, hoping that they'll get money by the time they're 65. So that looks like a 20-year difference. So our time is 20 years. They deposit $5,000 every year into the account that pays 1.25% interest, which is 0.0125 as a decimal. Compounded annually means it compounds once. What is the balance? So what is B? So I have B equaling my $5,000. I'm going to put square brackets for these outsides so I don't lose things. My rate divided by my N, which is a 1. N times T is 20 minus the 1, all divided by R divided by my N, which is a 1. Due to calculator, and you can accidentally have rounding error with decimals, we can't do these things little bits at a time. You have to type this entire thing into the calculator exactly the way that it is. I would recommend using Desmos because then you can watch the brackets and the parentheses and it will show you exactly what it looks like. You don't lose anything. So typing this exactly as it appears into Desmos, you get B to be 112,814.89263. It doesn't say anything about rounding. So this is our money amount. Money only has 2 decimal places. So we know we cut it off here. The 2 is bossing the 9 and says, you may stay there. So my balance is 112,814.89. Make sure you have your commas there. So my balance, so Rich and Laura will have $112,814.89 when they retire. Let's go ahead and check your understanding. How much more would Rich and Laura have in their account if they decided to hold off retirement for just 1 extra year? So we had our B, P, R, and T. Nothing is changing except for their years. They're no longer 20, it's now 21 years. We're still compounding once a year. We still have this as our rate, and this is still how much they put in every single time. We are just going to see how much more did they have. So B is, my P is 5,000. 1 plus, I need the fraction of my rate over my N. N times T is 21 all over my R divided by my N. So again, typing this all into the calculator exactly the way that it reads, I recommend Desmos. You get 119,225.0788. It doesn't tell us how to round. I need to cut it off right here. This 8 bosses the 7 up and says you need to move up 1 more. So our answer is 119,225.08. Make sure your comma is in there. So they will have $119,225.08 for retirement if they wait 1 year. But how much more is that? Because that's what the question wants to know. How much more did they gain? So right now, they could have had $119,225.08. But if they really did retire at 20, this is how much they would have had at 20. So what is the difference? $6,410.19 is the difference. So if they wait one more year, they will earn $6,410.19 more for retirement. So this is the final question because it wants to know how much more will be in their account. 6,000 more will be in their account. Let's extend your understanding. Carefully examine the solution to example 1. So this was what we had in our problem. This was your solution to example 1. It says, during the computation of the numerator, this up here, is the 1, this 1, being subtracted from this 20? And explain your reasoning. This 20 has nothing to do with this minus 1. This 20 is an exponent connected to this parentheses. Order of operations says you have to do the parentheses first, then the exponents, and then you will subtract. You do not do 20 minus 1. Order of operations does not say so. So because of order of operations, you need to solve this entire parenthesis before you can subtract the 1. Example 2. How much interest will Rich and Laura earn over the 20-year period? So according to our problems, their balance at the end of the 20 years was $112,814.89. This was at the end of the 20 years. We know that they put in $5,000 every year for 20 years. So how much did they actually put in? That is 5,000 times 20. So they actually put in $100,000 of their own. So if their bank account currently says $112,814.89, and we know that 100,000 of that is their very own that they put in, the leftovers is going to be how much they earned of interest. So they actually earned $12,814.89 in interest. Let's check your understanding. Use the example 1, check your understanding. So we're going to use that one. How much more interest would Rich and Laura have earned by retiring after 21 years? So following the same thing, the balance at the end of 21 years was $119,225.08. They paid $5,000 every year for 21 years. So how much money did they put in? They put in $5,000 times $21, which is $1,005 of their very own. So if they had this amount of money currently in their account, and we know that $105,000 of it is the own money that they put in, we know that the $14,225.08 is what they earned in interest. So we know $14,225.08 was earned on interest. If they lasted one more year, how much more interest did they earn from 21 from 20? So we don't want to know how much they earned at 21. We want to know how much more. So according to example 2, we know that $14,225.08 was earned after 21 years. But we know that $12,814.89 was earned after the 20 years. That came from example 2. So if we subtract the two, we find out that $1,410.19 is what they earned in addition to. So we learned that $1,410.19 is how much more they earned if they waited just one more year. Example 3. Linda and Rob opened an online savings account that has a 1% annual interest rate, compounded monthly. if they deposit $1,200 every month, how much will be in the account after 10 years? Because they are contributing to this account every single month. This is the equation that we use, which means we need to figure out B, P, R, N, and T. So reading it again. Linda and Robert opened an account. We have the 1% interest rate. So 1% as a decimal is 0.01. It's compounded monthly, which means it's going to compound a total of 12 times because there are 12 months in a year. They're depositing $1,200 every single month, and they want to know after 10 years. So we have P. I need R divided by N. N times T is 120, all divided by my R divided by my N. Again, type all of this in exactly the way that it reads into Desmos so you don't have any rounding error. Doing that, we end up having 151,379.849963 is your answer. Money has 2 decimal places, so we have to cut it off here. The 9 is bossing the 4 around and say you need to move up 1 more. So our answer is 151,379.85, putting in your placeholder commas. So how much is in after 10 years? $151,379.85 is in the account after 10 years. Now let's check your understanding. It says you're going to construct a graph, and you are going to construct a graph, but we're going to use Desmos for our graph. So first we need to figure out what equation are we typing into Desmos. They want us to take Rob and Linda's account for each month, but it wants us to try and approximate the balance after 5 years. So this was the account that we had for Bob and Linda, for Linda and Rob. So this was the equation we did for Linda and Rob, but it's telling us to graph this. So I need this to be an equation where we have a y equals. So my B is no longer a B. It's going to be a y equals, and we need an x in here. It wants us to approximate after 5 years. Our time is the exponent. So that means instead of this exponent right here of 120, we need to write the exponent of an x. So this is Linda and Rob putting in $1,200, compounding monthly at their interest rate, and we want to know at what month will get us what amount. That's what the question is. So typing this into your graph exactly the way that it reads. And we need to figure out what our x's and y's are going to be. So we know that our smallest x value, x's is how many times you actually put in a deposit. If I don't put in any deposits, that means I don't have any money. So my smallest x will correspond with my smallest y value of 0. I also need a largest. So I know my largest x, this is how many times we're depositing. They were originally doing 20 years. So my largest x is going to be 120 because that's how many deposits we did, 120. What is my largest y? Well, we noticed when they did 120 that our answer was $151,379.85. That was our answer. This was for 10 years. So we want to know 5. We want to know the in-between. So we're going to go ahead and graph this on Desmos using these constraints for our x and our y. So we need to graph this function. We're going to start with f of x equals to tell the computer, hey, by the way, we're graphing a line. Please graph the line for me, not solve a problem. We have a small parenthesis inside a larger parenthesis. So we're going to go ahead and start with the smaller parenthesis. And the smaller parenthesis is raised to the power of x. Now this parenthesis is minus 1, and it has an entire parenthesis around it with a 1,200 in the front. I now need to divide this entire thing by a fraction itself. And this is our line. It looks like a very vertical line, which doesn't help me with my answer. So we need to change our scales. So we're going to come over to the wrench, and we're going to change our scales. The x-axis represents how many months we are investing. The fewest amount of months you're allowed to invest is 0. So my smallest x value is going to be 0. The largest amount of times you are allowed to invest is 120. So we're going to invest a total of 120 investments. You also can choose how to skip count our x-axis. We're going to choose to skip count by 20 months. So we have our x-axis done. Now we need to do our y. If we invested 0 times, then we have the smallest y value of 0 monies invested. Now if we invested 120 times, our largest investment is going to be about $152,000. We need our y-axis to go from 0 to 152,000. So we're going to have it skip count and scale by $20,000 so it's easier to see. Now you'll see we do not have a vertical straight line. We now have something that we can read. So clicking the wrench, it's going to disappear. Our question asked us about 5 years, but we're not tracking in years, we're tracking in months. So 60 months would represent 5 years. So going up on 60 months until I click on the dot on the line, this 60 months, where'd you go? There you go. That is how we represent 60 months. That is $73,798.86 because you had to round. That's how much we got after 60 months, 5 years. So on Desmos, we found this coordinate point, 73,798.86. So this says at 60 months, which is what 5 years is, we found out that it was going to be $73,798.86 for 5 years.